The future of flight has just arrived, and it has Elon Musk's signature written all over it. Tesla has officially lifted the curtain on its 2026 super-electric plane, sleek, zero-emission aircraft that fuses breathtaking design, cutting-edge battery innovation, and astonishing speed. This isn't just another step forward in aviation. It's a leap that could permanently change how humanity travels through the skies. For decades, air travel has been chained to fossil fuels, noise, and inefficiency. But what happens when Tesla brings its EV mastery to the air? Can this invention finally make fossil fuel planes a relic of the past, and is Boeing ready for the turbulence ahead? The race to reinvent air travel has begun. Musk and Tesla are not simply building a plane. They're building the blueprint for a cleaner, faster, smarter aviation age. Before we dive into how this changes everything, it's important to understand just how big this shift really is. The superelectric plane isn't a concept or a dream, it's a tangible product with a production plan, its factory assignments, and a real rollout schedule. And it's priced to shock the world at around $79,979, less than most luxury cars and nowhere near the multi-million-dollar range of today's electric aircraft. Right now, flying often feels like an endless waiting game. Delays, curfews, maintenance holds, long lines each year, millions of passengers lose hours to inefficiency. Meanwhile, airlines struggle with stubborn fuel costs that make up nearly a third of their operating expenses. Prices stay high, service feels worse, and the system grows more bloated. Tesla saw this pattern and did what it always does: rebuild the system from scratch. What if a plane could charge like a car, update like a smartphone, and maintain itself with minimal downtime? What if the aviation industry could be simplified, modularized, and automated? That's exactly what Musk's new plan delivers. Tesla's first move was to bring the gigafactory philosophy into aviation. Instead of building aircraft the traditional way, piece by piece, bolt by bolt, Tesla designed the super-electric plane around modular construction. The fuselage, wings, battery packs, motors, and electronics are all independent modules produced with automotive precision. Each is assembled and tested separately before joining the main line. Fewer joints mean fewer defects, faster assembly, and greater consistency. And because every module has its own digital traceability, quality control remains airtight, even as production scales. The main production base, unsurprisingly, is Giga Texas, Tesla's largest and most flexible site. Its immense space and tooling already handle massive structures for vehicles like the Cybertruck. The same facilities can easily adapt to producing airframes. For the plane's energy systems, Tesla will rely on Giga Nevada. It's a longtime battery hub. Their cell packs, battery management systems, and inverters are already made at scale. These components will arrive at the aircraft line pre-tested and certified, drastically reducing wait times at the final assembly plant. This integration means aircraft can roll out more quickly, with better performance and lower costs than any conventional manufacturer can manage. Once production expands globally, Giga Berlin and Giga Shanghai will follow. Both sites already have proven track records of localizing supply chains and maintaining high output efficiency. By building the same plane in multiple regions, Tesla gains resilience against disruptions and trims shipping costs for bulky components. Each plant becomes part of a synchronized network, capable of rebalancing production in real time, something unheard of in aviation. The result is a new kind of aircraft industry, one where modular efficiency replaces the patchwork systems of the past. This approach cuts costs dramatically. With fewer parts and faster assembly, Tesla can build more airframes per year, keeping unit prices low. And since the core system's battery, motor, and electronics are standardized, maintenance becomes easier and cheaper. Instead of taking a plane offline for weeks, technicians can swap a single module, test it digitally, and send the aircraft back into service. The outcome for customers is lower ownership costs, higher availability, and reliability that feels almost automotive. Powering this revolution is Tesla's proven energy technology. Decades of EV experience have given the company an enormous head start. The same stack battery pack, motor, inverter, and management system that drives millions of cars can now power aircraft. Efficiency is Tesla's biggest edge. A typical electric drivetrain operates at around 90% efficiency, meaning almost all the stored energy becomes thrust instead of heat. In comparison, combustion engines waste most of their energy as heat and friction. In aviation, where every watt matters, that efficiency means longer flights and more payload for the same charge. Noise is another game changer. Without combustion cycles, the super-electric plane produces far less sound than any gas-powered aircraft. Most of the remaining noise comes only from airflow and propeller motion. The result is a quieter, smoother, and far more pleasant flight experience, especially for regional routes where noise pollution is a major problem. Tesla's engineers are tuning the inverters and motors with surgical precision, optimizing not just thrust but acoustic comfort as well. Then comes energy infrastructure. It's the backbone of Tesla's entire ecosystem. The same supercharging network that powers cars will now extend to airports and vertiports. Supercharger V4 stations already deliver over 300 kilowatts. And with some tweaks, they can serve aviation needs as well. Where the grid is weak, Tesla's megapacks act as energy buffers, releasing stored power into the aircraft before slowly refilling from the grid. Powerwall units manage smaller sites and auxiliary systems. With over 5,000 public airports across the U.S., the rollout is less about building from scratch and more about intelligent placement, creating a web of fast, clean charging points that make electric flight viable. Imagine this: a 200 kilowatt pack recharged from 10 to 80% in just over half an hour. That's enough for most regional hops with energy to spare. Add in Tesla's remote monitoring, and the whole process becomes as effortless as plugging in your car. The same logic applies to maintenance. No oil changes, no exhaust systems, far fewer moving parts. Everything is monitored through sensors and over-the-air diagnostics. When an issue begins to form, the system catches it before it grows. That means less downtime, lower costs, and more time in the air, exactly what operators and pilots need. Tesla's minimalist design philosophy doesn't stop at the factory floor. It's written across every line of the aircraft's exterior. Every curve, every seam, every surface serves aerodynamic purpose. The body is designed to reduce skin friction drag, which accounts for nearly half of a plane's resistance during flight. By simplifying the exterior and smoothing out joints, the super-electric plane slices through air with uncanny efficiency. Fewer fasteners and cleaner surfaces mean less turbulence and more range. To achieve that, Tesla uses large composite panels and advanced aluminum alloys. These materials cut weight by double-digit percentages and resist corrosion far better than traditional metals. They're strong, yet flexible, making repairs faster and reducing fatigue over time. If a section ever needs replacement, its modular technicians simply detach one piece and snap in another. That modularity, again, shortens downtime and extends service life. Tesla's attention to usability shows up everywhere. The door handles are flush to minimize drag but easy to operate. Anti-slip steps, inspired by the Cybertruck's rugged texture, make boarding safer, especially for older passengers. LED lighting surrounds the airframe for superior visibility, lasting tens of thousands of hours, far more than the old halogen bulbs most aircraft still use. Add in 360-degree cameras and proximity sensors, and pilots can taxi and park with car-like precision, avoiding scrapes and improving turnaround speed. Even small details like the positioning of the charge port or the status light ring save precious minutes between flights. Inside the cockpit, simplicity reigns. The Tesla super-electric plane borrows directly from the company's vehicle interface philosophy. A single large central display shows flight data, system status, and navigation information. While critical controls flaps, radio, lighting still have dedicated physical switches for instant access. It's the perfect blend of digital flexibility and tactile reliability. The fewer menus a pilot must scroll through, the less cognitive load they carry. Reducing errors and increasing focus during takeoff and landing, Every inch of the interior serves function and comfort. Seats are supportive yet lightweight, designed with ergonomic precision and soft, breathable vegan leather. Lumbar shaping keeps the body stable during longer legs, while wide windshields and slim pillars give unmatched visibility. Pilots can see ramp traffic, signage, and obstacles with ease. That translates into safer ground handling and faster pre-flight routines. Cabin comfort isn't just about luxuries, it's about efficiency. Tesla equips the aircraft with a heat pump system that delivers both heating and cooling with minimal power draw, preserving battery life while maintaining cabin temperature. Materials are selected for durability and easy cleaning, meaning the cabin keeps its fresh look after hundreds of cycles. Acoustic insulation and low-frequency active noise control create a calm, quiet environment that reduces fatigue. Pilots can fly back-to-back routes without the usual EXA,